Hello, this is Professor Mark Werwath. My topic today is chemical industry's dark side, the case for green chemistry. These slides were put together fundamentally to support a case study from the Harvard Business School Press that focused on an introduction to the green chemistry field, mostly for business and non-chemical professionals. I want to start by saying this topic is somewhat unknown or somewhat limited to the public in terms of what they're aware of. The public tends to look at specific contaminants in specific situations and specific instances. For about 5 years, we've been talking about Flint, Michigan and the lead problem in the public drinking water supply. It's been a problem for 5 or 6 years where literally the entire city of Flint is being distributed bottled water because the drinking water from the tap is unsafe to drink due to high levels of contamination from lead. First of all, this is a problem that is not limited to Flint. In fact, it's been found in similar situations across the country, including Chicago. The latest here being Benton Harbor, where literally Benton Harbor residents have been, and there's something like 9,600 of them, are encouraged to use bottled water because, again, the drinking water is unsafe due to lead. Lead contamination comes from a variety of sources, one of which is the actual pipes themselves. Lead service lines have been in place prior to the mid-70s, and they were common across much of America, and they have never really been replaced. So this issue with lead in the water in Flint, Michigan, not only has not been solved for Flint, it really hasn't been solved anywhere else in the country to my knowledge. So this latest issue being in Benton Harbor. So the state of Michigan has its problems. The outline of this talk, I'm going to start with talking about forever chemicals. I will then switch quickly to Haber-Bosch, which is a method for producing nitrogen and ammonia. And then we're going to go from there to contaminated environment, including some spills and disasters. And then we're going to finish up with what is green chemistry, the 12 principles, and a video from the Michigan Department of Environment and green issues. So PBTs, what are persistent bioaccumulative toxic chemicals? PBTs, right? Chemicals that are persistent in the environment, bioaccumulate in people and or wildlife, and are toxic. They're called PBTs, right? Because of these features, as long as they remain in commerce, meaning as long as they remain in production and they're being distributed amongst the market, they will threaten the health of humans and of wildlife, and I would say the environment as a whole. So included in this list would be PFAS. These are forever chemicals. This is an article from The Guardian back in September. These are incredibly strong carbon fluorine bonded chemicals that do not biodegrade, right? These bonds are so strong, they will persist and accumulate in soil, water, air, wildlife, and unfortunately our bodies. It's unfortunate as well that something like 97% of Americans have been found to have some degree of PFAS in their blood. It's also been found in human breast milk, right? What does this mean? We're not sure what it means. We do know that it's been linked to fertility problems, changes in metabolism, increased cancer and obesity rates, but the long-term consequences have not been fully studied. So we don't know what it means to have PFAS in the blood. However, we know that once it's in the system, it winds up ending up in our water system. So as soon as it hits the environment, thanks to erosion or being dumped down drains, it winds up being in the water supply, and it's very difficult to remove. It's almost impossible to remediate. Water treatment plants can use activated carbon to filter out some, but not all PFAS and other contaminants. Mapping the universe of PFAS chemicals, and there's something like 5,000 such PFAS chemicals, right? But we're trying to understand which ones are really harmful, which ones are not. It's going to take decades to figure that out, right? Globally, PFAS has been widely documented in rivers, lakes, wetlands, and almost every ocean. They are on Mount Everest. They are in the Arctic sea ice. So PFAS, even though they've only been around in this, from a production standpoint since something like the 1940s, so it's less than 80, something like less than 80 years, we're seeing it as a pervasive contaminant across the entire planet. They are obviously more prevalent where there's lots of people, such as European cities, river catchments. Some additional facts. Basically, you see in the upper right here some abbreviations and various chemical names. I am not a chemist, so I'll warn you about that now. It's probably pretty obvious, but I am obviously interested in the environment. I'm worried about public health and safety. And I personally filter all the water I drink in the household because I am concerned about these things. PFAS is not just found in the water, though. It's found in food packaging, in commercial household products, drinking water, living organisms. It's found in frying pans, which is why I included this image of a Teflon-coated frying pan. So the health risks, right? Low infant birth weights, immune system effects and issues, disrupting thyroid, and links to at least 5 or 6 different types of cancer. So these are non-trivial issues. And clearly PFAS is just one example of many of contaminants in the environment, right? We're going to switch quickly to Haber-Bosch because the Haber process of nitrogen fixation is something that's enabled humanity to grow to the levels of close, 8 billion or so of us on the planet, being able to be supported with food and nutrients on a consistent basis is to a large extent thanks to Haber-Bosch. So I'm not here to trash the process per se or to say there's anything negative, except for one thing. There is a huge environmental footprint and a huge impact that these processes have had on the environment, and that cannot be understated, right? So Haber-Bosch is fundamentally an artificial nitrogen fixation process. It's the main industrial procedure for the production of ammonia today, right? Fritz Haber, Karl Bosch, in the first decade of the 20th century, invented this. These are large-scale processes. These are processes that scale up. As a result, we're talking 250 million tons of anhydrous ammonia being produced per year. Absent this, we would probably need 3 or 4 times the amount of arable land currently in production in order to produce the amount of food that not this country, but this world needs every day, right, to feed 8 billion people. So that's the good news, right? The bad news, right? The energy intensity of the process contributes to climate change and other environmental problems. The leaching of nitrates into groundwater, rivers, ponds, and lakes has expanded dead zones, not just in ocean waters, but also issues in various freshwater lakes as well. So we're talking about, these are the results from the recurrent eutrophication, atmospheric deposition of nitrates and ammonia that are affecting natural ecosystems, higher emissions of nitrous oxide, the third most powerful and important greenhouse gas following CO2 and methane. So the Haber-Bosch process is one of the largest contributors to a buildup of reactive nitrogen in the biosphere, causing anthropogenic disruption to the nitrogen cycle. Since nitrogen use efficiency is less than 50%, farm runoff from heavy use of fixed industrial nitrogen disrupts biological habitats. It winds up in the water streams. It winds up in the rivers. It winds up the nitrogen, the excess nitrogen winds up in our lakes, right? We see these dead zones as a result of that, and these toxic algal blooms, right? So basically, in many cases, the people view this as both kind of a positive negative, right? The Haber-Bosch process has served as the detonator of the population explosion, right? You can look at that either way, but we're enabling the global population through Haber-Bosch to increase from what was 1.6 billion people in 1900 to 8 billion people now. So one issue, right? Another issue, coal emissions, right? So the NIH, National Institutes of Health, have published this map, and this shows where toxic coal emissions are prevalent across the country. You see a pretty intense cluster right around here in Chicago. So some of this comes from coal dust. Some of this comes from transportation of coal, which happens quite a bit through the Chicagoland area, thanks to our extensive rail network, right? The other part of it comes from actually burning of coal when it comes to power stations in the Midwest and the East Coast, as you can see, and parts of the South. So major issue there. Of course, this is a national priority list of EPA Superfund sites, right? Over, 1,200 or so. across the country. These are sites that are so contaminated that they literally have been prioritized for cleanup. But in most cases, we don't have the resources, the financial resources or any other resources. This has not been a priority in the administrations for the last 20 to, I would say, 40 years, ever since about 1980. Why is that? Well, the politics of the situation, but we're not putting the resources needed into the EPA to enforce the Clean Water Act, the Clean Air Act. And in many cases, these kind of cleanup sites have been left to degrade over time. So this is part one of the video. I'm going to stop now and basically go to part two in the next video, where we'll be covering a little bit more detail on some other aspects of green chemistry, and actually what is green chemistry.